Part 2. Part 2! Okay, here we go. The diagram, CXD is a right angle as marked. Name another right angle. Well, if that's a right angle, then you know DX is perpendicular to AC, so I can also say the one on the other side over here is a right angle. Angle DXA. Two congruent supplementary angles. Well, if they're congruent and supplementary, they both have to be 90. So I already know about two 90-degree angles, that one and the one they gave me. Two non-congruent supplementary angles. Okay, those would be easy to find as angles along a line. Let's do AXE. So, like, you know, this little angle in here is going to be supplementary to the rest of it. So, like this angle out here. The yellow part and the green part have to add to 180. AXE with EXC. Two complementary angles. Let's get this junk out of the way now. Two complementary angles would be angles that add to 90. Well, I said this was 90 already. So let's say AXE. Let's say this little angle right here is complementary to this little angle right here. AXE and EXD. Those ought to add up to 90. There's other choices for these, of course. Any two angles along a line will be supplementary. And any two angles that make 90 degrees will be, that's an E, by the way, that make 90 degrees will be complementary. Okay, 21. Move this down yet again. Sorry about my aim here. All right, find the values of x and y. Well, I know when two lines intersect, really the only thing I can be sure of is that the vertical angles are congruent. So I am sure that 2x plus 5 is equal to 4x minus 35. So solving that algebraically, and isn't it nice not to have to justify all these steps all the time anymore? You don't have to. You can just say x is 20. Okay, so I found that one. I just need to find y now. Well, if x is 20, I know that this is 45 degrees. 2 times 20 plus 5. Or 4 times 20 minus 35. That's also 45. That's a nice check that my x must be right, because that makes these both 45. Well, if these are 45, I know these are 135, because that's 180. You know, along the line, it's 180, so these are 135, including 6y plus 15. 6y plus 15 is 135. I can actually solve that for y, and I get, guess what, again, y equals 20. It's kind of strange that they're both 20, but I found them both. They're both 20. Which one of the following statements cannot be written as a true biconditional? Well, if it's written as a biconditional, it's really, they're always true, which makes this kind of not really a nice direction down here. So let's just talk about this first. Which one of the following cannot be written as a biconditional? So we're looking at a statement plus its converse both being true, then it'll be possible. Which one cannot? Any angle that measures between 90 and 180 is obtuse. Well, that works, because if it's obtuse, then it's between 90 and 180. Any angle that measures between 0 and 90 is acute. Well, if I read that backwards, if it's acute, then it's between 0 and 90. That would be fine. If two angles measure blah, 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 then they are supplementary. Well, if I read that backwards, if they're supplementary, then they're this. Not exactly true. So I think that's going to be the problem. If the sum of the measure of two angles is 180, then they're supplementary. If you read that backwards, if they're supplementary, then the sum is 180. That's fine. So it's C. I can't write the statement that I chose as a biconditional because I chose the one that cannot. So that doesn't make sense. So I changed this in class to write any other, just so we can practice this. Any other statement than the one you chose, then it'll work. So I'm going to say, oh, how about B, because it's nice and short. An angle measures, remember the magical statement here on biconditional is this if and only if thing. So you got to repair the grammar a bit to get this to work, but I need 0 and 90 on one side of the if and only if, and the acute on the other side of the if and only if, and then just make sure it reads so that it makes sense. An angle has a measure between 0 and 90 degrees, if and only if. I should have typed this. It's a lot of words. It is acute. Hopefully you can read that. But if and only if is the thing that makes it a biconditional. That is the biconditional. Ooh, I can put it right here in this box. Biconditional magic happens with that. All right. Okay, I got to look at the book for these. Okay, then the next few are from the textbook. There wasn't really room to show these on your paper, but if you look in the book, this is sort of what you'll find. All right, before you do any thinking, copy this in as we said. Given goes there. This thing goes here. The first statement you're asked, or you're told is given, goes there. The stuff you're trying to prove goes at the bottom. And then mark up the figure any way you can, and see where you can go from there. All right, I know 2 is congruent to 3, so I can go ahead and mark those. Then you can either look at the bottom and go, okay, I know for sure how this has to happen, and I might be able to fill in this step right before that. That's kind of tricky here because there's lots of reasons why 2 angles might be congruent, and this one's over here and this one's over here. It could be a variety of reasons. So I don't really know this yet, or I don't know what comes right before it. The next thing to maybe try is look at the beginning and go, well, if 2 is congruent to 3, and look at that, then I know blah, blah, blah has to happen. Well, that's not really obvious either. Next trick to try is go look at the picture and go, well, what do you know? Is there anything you know has to be true? Well, that's kind of easy here, actually. Vertical angles seem to jump out at people. I know that 1 is congruent to 3 because it's vertical angles, but as long as I'm at it, I might as well say 2 and 4. And I can put all that in the same step because it's the same reason. That's all step 2, and it's all vertical angles. Now, is that helpful? Well, 2 is congruent to 3, 1 is congruent to 3, 2 is congruent to 4. A lot of stuff is congruent. And if I look at the way I've marked stuff in the picture, I'm headed for this. 1 is congruent to 4. I've already marked it. I just got to name the reason here. And really, this is all 1 is congruent to 3, 3 is congruent to 2, 2 is congruent to 4. Therefore, 1 must have to be congruent to 4. This is one great big chain of events, all being congruent. All 4 of these things in this club are congruent. That's called transitive. Thing 1 is equal to thing 2, and thing 2 is equal to thing 3, then thing 1 is equal to thing 3. Actually, we have 4 things here, so it's just a little bit longer train, but same reason. All right, same thing, number 8. Let me fill that in. All right, magically that's done. I've got the given and the 2 proofs in the right place. There's no way to mark this stuff on the figure, which is kind of a bummer. I'm gonna invent a way right now. 3. Let's put these in sets. Let's say 3 is supplementary to 1. 3 and 1 make 180. And also 4 and 2 make 180. Right now I don't really know if anything's equal there. I just know 3 and 1s are supplementary and 4 and 2 is supplementary. That's not really a standard way to do that, but I'm going to just do that for now so we can see it. I'm trying to say why 3 is congruent to 4 here in the end. Again, at the end of this proof, there's no reason why angles have to be congruent really in general, so I can't really start at the end. I can start at the beginning here and go, okay, look, 3 and 4 are both supplementary to these 2 other angles. And that kind of sounds like a theorem we've had before, which if 2 angles are supplementary to angles that are congruent, then those angles must be congruent to each other. So if I could ever say 3 is congruent to 4, which I probably can't, then I'd be able to say 1 is congruent to 2. But by the same token, if I could say that 1 is congruent to 2, then I'd be able to say this by that theorem that says if angles are supplementary to congruent angles, then they are congruent to each other. So if I could just get 1 congruent to 2, I'd be in business. Oh, wait, look, there's vertical angles, which you might have seen first, actually, before thinking through the way I did. This is just like the last proof. See how vertical angles are so popular? And so easy to spot, really, actually. Vertical angles. Okay? Technically theorem. I think I got it then. If 1 and 2 are congruent and 3 and 4 are supplementary to angles that are congruent, 3 and 4 must be congruent to each other. That is called, stuck in the middle of chapter 2 here, supplements to congruence. If 2 angles are supplementary to angles that are congruent, then they must be congruent. 3 makes 180 with 1, 4 makes 180 with 2. Whatever 1 and 2 are, they're the same. So 3 is like 180 minus 1, 4 is 180 minus 2. But 1 and 2 are the same, so 3 and 4 have to be the same. All right, and then here's number 9. Again, let me fill that in. Okay, and this one I'm told that AC and BC are perpendicular. So my angle marking is really big there, but this is one great big right angle. That's really not a great picture. It's better in the book. And 3 and 1 are complementary. Okay, so kind of did this before. That I have a set here. Something's going on with 3 and 1. They're not the same, but they add up to 90. So why does 3 have to be congruent to 2? Well, if you think about it, think about the last proof. This is kind of the same thing. 3 and 1 make 90. Well, the other thing I'm given here is that 1 and 2 sort of make 90 because they make a right angle there. So let's bank on that fact. I can't. It doesn't really say here that 1 and 2 make 90 yet. I'm going to have to say that it does before I can use that fact. It was given to me this way. I have to kind of convert that to saying 2 is complementary to 1. Now, why is 2 complementary to 1? Well, they're tucked together in this right angle. That has a name. If you look at your menu, it's called the split perpendicular theorem. Isn't very popular, but this is what it's for. And now I've got the same story as last time. 2 and 3 are both complementary to the same angle, so they must be congruent to each other. That's the complements to congruence theorem, which is on the same page as the supplements to congruence. All right, that's it for the stuff in the book. And if I had done my numbering right, this would actually be number 27. Oh, you can't see the top of that. I can't move this thing down for you. There we go. Barely get my step 5 in there. All right, so this is the last proof on the page, I believe. I'm given all this stuff. SV is a bisector of RST. RU is a bisector of SRT. Well, I really want to mark that. SV is a bisector of this stuff because the definition of bisector would tell me that these two are the same. I bet you that's in the proof somewhere. Where is it? Oh, it's not in there. Well, that's a bummer. Okay, maybe I don't need that. RU is a bisector of SRT, so that goes right in the middle of these two guys. RST is congruent to SRT. Oh, I'm going to mark this then. That big angle there is congruent to that big angle there. That's going to be helpful. And prove that 1's congruent to 2. Well, this stuff's given. All the given stuff goes in here, but in these pre-filled out ones, you got to be careful. Sometimes they split stuff off. This part's in step 1. If I say given here, I've got that taken care of. But this piece doesn't show up until, well, must be there. Measure of angle RST is congruent to the measure of angle, measure of angle SRT. Okay, so they split up the given. That might be helpful when I go to read the problem, but it's kind of confusing here at the beginning. All right, why is 1/2 of RST or 2/2 of SRT? Well, I keep warning you about this half business. The half should alert you that we're talking about theorems and not definitions. This isn't midpoint, though. Of course, this is angle bisector. Okay? All right, so and then I have this was given, and that's leading me to this point. Now here, it might be a good idea to look at the flow of the logic here. They said, they did all this to set up the fact that 1 is half of RST. Let me get this out of the way here, this blob. 1 is half of RST, 2 is half of SRT, but wait a minute, RST and SRT are equal. And those are, they mentioned those because they came up right here. So I know that if SRT and SRT are congruent, I could actually just convert those to saying, well, they're the same as the half of each. What happened from step 3 to step 4 is I just introduced the half. I basically multiplied both sides of that equation by half. I did some algebra here. And I did that because, look, this half RST and half SRT were mentioned up in these steps. That kind of tells me, oh, that's equal to that, and that are equal from here and here. So that must mean these two things are equal. Oh, I could have filled this in at the beginning. I knew I was headed this way, right? Because of that. Oh, I forgot my measure again. That's weird. And that's this. Okay. From the fact that these two are equal here, and these two statements are one great big transitive, or substitution. I basically am taking the stuff from step 2 and I'm subbing in these for each other because I know they're equal now. Or I could say this is now angle 1 and this is now angle 2 from step 2. Okay, I gotta explain that later in class. Oh, that must be the end. Okay, after this on the page, it says what you're supposed to study. I'm almost out of time anyway. And good luck. That's it from the video lesson.